Hello, so this was the time first derivative of our f of x. Now here the assumption on s are going to be between 0 and 1, and if we calculate now f at 0, then this whole term will go out, this whole term will vanish to 0 because of this, and what we are left with 1 minus s times 1 times minus 1, and which is minus 1 minus s, which is less than 0. So this implies that x1 to be 0 is a stable equilibrium point or equilibrium solution. Next, we calculate the same f prime at 1, which is going to be, this will be 1, so this will be s times a minus a plus 1 plus this is going to be 0, so we are left with this was minus 1, so we are left with minus s, which is less than 0, and this implies that our x3, which was equal to 1, is also a stable equilibrium point. Next, what we can do, next we have to show that x2 is unstable. We have to show that x2, what was x2? We have calculated the expression for x2, and x2 was between, in fact, 1 and x3. Now we will show that this x2 is unstable. So let's do it. So as we know that our f prime at x is given by s times x to the a minus 1 times a minus x times a plus 1 times 1 plus 1 minus s times 1 minus x to the a minus 1 times minus 1 plus x times a plus 1. Now x2 we can substitute in this, and then f prime at x2 is equal to s times x2 a to the minus 1 a minus x2 a plus 1 plus 1 minus s times 1 minus x2 to the a minus 1 times minus 1 plus x2 times a plus 1, and over here. But we know previously that for x2 we had a relation, and the relation was this one, s times x2 to the a minus 1 was equal to 1 minus s times 1 minus x2 to the a minus 1. This was the step when we were calculating x2, so you can figure this out. Previously we have seen it, so I can put this value over here, and as a result I'll be left with something that is f prime at x2 to be equal to 1 minus s times 1 minus x2 to the a minus 1 times a minus x2 a plus 1 plus 1 minus s times 1 minus x2 to the a minus 1 times minus 1 plus x2 to the times a plus 1, and this is a plus 1. Okay, so this term is common in both, and we can snatch it out to get something which is f prime at x2 to be equal to 1 minus s times 1 minus x2 to the a minus 1 times a minus x2a minus x2 minus 1 plus x2a plus x2, and we can perform some of the algebraic manipulations, such as this x2 will be cancelled with this x2 and this x2 with this, and we will be left with something that is f prime at x2 to be equal to 1 minus s times 1 minus x2 to the a minus 1 times a minus 1. Now let me state the assumptions on a. So the assumptions on a are a greater than 1. Since a is greater than 1, so this quantity is positive. And we also know that x2 was between x1 and x3, in other words 0 and 1. So x2 is less than 1, hence this is also positive, and this is also positive from the assumption on s, so this is also positive. So product of these three positive numbers is positive, and this implies that f prime at x2 is positive, and hence from linearization theorem we can conclude that x2 is an stable equilibrium point or equilibrium solution. So what is happening basically, physically or practically? So we can put comment on this. So let me draw xy xt plane. So this is my x and this is my time axis, and we all know that our equilibrium points were x1 to be 0, x2 was between x1 and x3, and then x3 was equal to 1. So in other words, we had over here, here, and then over here. This is 1, this is 0, and this is our x2. So now let me consider a scenario. Now let's consider this. So let's say this is a society. If in the society at time 0 x of 0 is equal to 0, what is the meaning of this? This means that in this society there is no one at time t equal to 0 who speaks language x. So no one in this society is speaking language x at time 0 by this. So this means only y is spoken over here. And now this is my initial condition, and if I solve this x dot to be whatever it was expression, then since this x0 to be 0 is a stable point and it is starting over here, so it has to be attracted towards this because stable points are attracted. So the trajectory will keep on this, it will remain on this. What is the meaning of this? This means that if at time 0 no one is speaking language x in this society, so that means that in long run as time will pass, no one will be speaking English language x, everyone will be just talking y. If in a society at time 0 no one is speaking x, that means no one will speak language x by this model that we had considered, this one x1 to be whatever it was, s times 1 minus x times x to the a minus 1 minus s times x times 1 minus x to the a. This was the model. Now consider another scenario, and this is the scenario. Let's say this is a society where we are taking this initial data. This initial data means that all the population is talking language x, no one is talking y. So in this society everyone at time 0 is talking speaking the language x. So at time 0, that means we are taking initial data here, and this x equal to 1 is a stable point, so it will keep on this line. The solution will be this, because it will not move to this, because this is a attractor, stable. So if it starts on this, it will stay on this. That means what? That means that if everyone is talking language x, so everyone will be talking language x. No one will be coming to speak y by this model. So everyone in long run will keep on speaking language x. Now let me consider third scenario. Now in this scenario, now suppose that there are people. Now consider x of 0 to be non-zero but less than x2, this point. So initially there are people, there are some fraction of people in the society who speak x, and also there are people who speak y. So but this fraction of people at time 0 who speak x is less than x2, that means the initial condition is somewhere over here. So that means that in long run it will it will be attracted towards the 0. What is the meaning of this? This means that at time 0, if the people who speak language X are less than this X2, this means that this model predicts that if at time 0 the fraction of people who speak X is less than X2, then the language will die out. In other words, in long run, this language X will wipe out, will vanish. Now consider, so only this will survive in this case, if X of 0 is less than X2. What if we consider another scenario, this one, and in this case, at time 0, there are people who speak language X, but it's greater than X2. In other words, at time 0, there are people who speak English X language, and those people have the fraction which is greater than this X2. So that means somewhere over here. And this means that in long run, here we have unstable point at X2. This is unstable. This is unstable. So this trajectory has to go to this X1. That means what? That means that if at time 0, people speaking language X have the fraction greater than X2, then X2 will survive in long run. Y will wipe out. So this will be the X of t equal to 1 means that everyone will be, so this will be the whole of this population. That means that everyone will be talking X language and Y will die out. So this means that if X of 0 is 0, that means no one is talking at time 0x, so no one will talk X, no one will speak X. If everyone is speaking X at time 0, then everyone will keep on speaking X. And if X of 0 is less than X2, that means that X will die. And if X of 0 is greater than X2, that means that X will survive and Y will die. What is the other meaning of this? This means that two languages cannot coexist together in a society by the prediction of this particular model that we considered. Thank you so much.